Every once in a while, a student will look at an expression and will use the rule regarding dividing exponents strictly as it's said. So in other words, they will always take the top exponent and subtract from it the bottom exponent, even though we know there are more x's in the denominator. Well, that's okay, but it's going to leave the student with a very different answer. So let's look at this problem. 4 over 24 reduces to 1 over 6. Now, if we take x to the third over x to the ninth and take 3 minus 9, we get negative 6. So we're left with an x in the numerator to the negative 6th power. It's very uncommon to have a final answer with an exponent that's been left negative. This would not be an appropriate final answer. So what does it mean to have a negative exponent? What it means to have a negative 6 in the exponent of that x is that that x is on the wrong side of the fraction. In other words, while the x is in the numerator, it should be in the denominator. And we know that from the last lesson because 9 minus 3 is 6 and there are more x's in the denominator. But even if this student did decide to do 3 minus 9, they could just fix this problem by making it 1 over 6x to the 6th. So notice the 6 did not change places. That 6. The only thing that switched was the x to the 6th because of that negative exponent. Similarly, if we had to simplify these expressions, we would know that we can't leave a negative exponent in our final answer. So how do we fix that? Well, the 4 has a positive exponent, so it's going to stay right where it is. But the x to the third is going to jump down to the denominator, and that becomes 4 over x cubed. Now I know what you're thinking. There is no denominator to that original expression, but you always need to remember that an expression can be written over 1. How about the second example? Very similar. The 2 stays in the numerator, the 9 stays in the denominator, the x to the third is going to jump down into the denominator, and the y squared is going to remain with it. Now you'll notice I wrote the x in front of the y. That's just to stay alphabetical. So now what would we do with a problem like this? Well, there are actually 2 methods to do this problem. What I'll do is I'll start by using the higher of the 2 exponents, which in the case of the x's is the 3, and in the case of the y's is the negative 2. So I'll reduce the 4 over 6, I'll make that 2 over 3, and then since the x's have a higher exponent in the denominator, I'm going to take 3 minus negative 2. Be careful, 3 minus a negative 2 is actually a positive 5, so that positive 5, x, will go in the denominator. Similarly with the y's, negative 2 minus negative 5 is actually positive 3, and that positive 3 is also going to be in the denominator. So that would be an appropriate final answer. Now, let's say that we want to do something slightly different. Some students would like to take that original expression and rewrite it with all of the exponents as positive. So for example, they would take the x cubed, move it to the bottom, take the x squared, move it to the bottom. The x cubed is already on the bottom, rather. They would take the y squared, move it to the top, and the y to the 5th, and move it to the bottom. So if you take a look back, all that we did is we took all the negative exponents and we moved them to the different side of the fraction. Now, they're on the same side of the fraction, so I just go to my rule of multiplying. So they actually will equal x to the 5th, since I'm adding exponents. 4 over 6 gives me 2/3 x to the 5th, and then going back to my other rule, y to the 5th, that's the bigger exponent. 5 minus the 2 gives me a y cubed. So there's just another way to get the answer from earlier. It's really up to you as far as which method you prefer. One last trick regarding negative exponents. If I have an expression and I have a negative exponent that that entire expression is being raised to, what I may want to do is just take that expression and flip the entire thing. Now, that negative exponent becomes a positive because I've just taken the reciprocal of my expression. So now I can distribute that exponent like normal, y to the fourth, 3 squared, x squared, and that simplifies to y to the fourth over 9x squared. Similarly, even though there is no fraction, I can rewrite this as 1 over 4x cubed and make that now a positive 2. 1 squared remains 1, 4 squared is 16, x cubed squared becomes x to the 6th. So my advice with those negative exponents outside of your expression is to simply take the reciprocal of your expression and then distribute the positive exponent.